Okay. The Resilience Hub Battery Energy Storage System.
Good evening, Mayor and Town Council. I'm here to present the Resilience Hub Battery Energy Storage System. Just a brief reminder, the Resilience Hub consists of a solar voltaic system, solar panels, and a battery energy storage system, or BESS. The battery used for this project is from EPC Energy E90 series. It uses a leveraging lithium iron phosphate battery technology, or LFP. LFPs are currently in use in the U.S. for standard range Tesla Model 3 and Model Y, Ford Mustang Mach-E's, and Rivian R1s and RT trucks. The battery is UL certified. It is also California Energy Commission listed and approved for use under California Public Utility Commission's self-generating incentive program. E90 series has a total energy storage of 246 kilowatt hours, which is comparative to two Ford F-1 Lightnings, which is a total of 262 kilowatt hours. For reference, the Moss Landing fire was about 1,200 megawatt hours, or 1.2 million kilowatt hours. Moss Landing is roughly 4,878 times larger than the battery at Resilience Hub. Here's a list of E90 series certifications. The E90 series has multiple UL certifications. UL Solution is the industry standard for testing, inspections, and safety certifications. The BESS also meets National Fire Protection Association standards. The NFP sets standards with the intent of eliminating death, injury, property damage, and economic loss due to fire, electrical, and other related hazards. Lastly, the BESS is 2022 California Fire Code Section 1207 compliant, which is for electrical energy storage systems. The Public Works Department made an emphasis of fire safety for the BESS. The main concerns with batteries is thermal runaway events and deflagration, which is both addressed by the BESS. Thermal runaway can occur when a cell failure causes other cells to fail, resulting in a self-sustained chain reaction fire or deflagration. UL 9540 and UL 1973 certification addresses the thermal runaway issue, while NFPA 68 addresses deflagration. Below are some of the E90 series additional safety features. There is Advanced Battery Management Systems, BMS, which continuously monitors the battery's health, voltage, current, and temperature, and helps prevent overheating, overcharging, and other failures. There's Advanced Controllers, which gathers data in real time to safely operate the system and sends alerts directly to the town. There will be a robust 8-inch concrete wall that is 2-hour fire rated. There will be a floodgate system that will provide floodproofing 1 foot above base flood elevation. There is an integrated cooling mechanism that automatically provides air cooling and forced air whenever required to maintain optimal operation temperatures to reduce the risk of fires. Here are some additional safety operational measures and emergency response. There will be regularly scheduled maintenance inspections required to detect any potential issues. There will also be temperature monitoring that will cycle the BESS between 0 and 40 degrees Celsius to avoid any potential hazards. The contractor Gridscape will also develop an emergency response plan for potential BESS incidents and evacuation protocols to ensure occupant safety during emergencies. And here's a quick project update. Construction is now scheduled for next week, the week of April 30th, to begin. There will be construction signs posted at the Magnolia lot, as well as the corner of Magnolia Ave and San Anselmo Ave, letting drivers know that the Magnolia lot is closed. And for updates, you can refer to our project website page that will be updated weekly, and we'll have maps for where residents can go park in downtown area whenever there's impact to the Magnolia lot. And here's a quick visual of the timeline. Even with the slight delay, we are still scheduled to finish before the end of June. Any questions?
Questions?
I do have one. So I thought, correct me if I'm wrong, but I thought we were considering going more than 1 foot above BFE, base flood elevation.
Yeah, we looked into it, and cost-wise, it wasn't really worth going another foot above. We can certainly look at it again, but it's already going to be about 66 inches high. But yeah, we looked into the cost, and it wasn't really worth the extra foot. For
Okay.
the,
And is that something that can be altered in the future? Let's just say sea level rise is
yeah.
faster than we think it's going to be. And is that something that can be adjusted?
Yeah, so we are actually getting a new floodgate system. It's going to be stackable logs, so it'll be easier for the crew to stack them up. It'll be about 6 to 8 inches high, and it could go high, so there's always a possibility to have the pre-sprays, the company that we buy from, to add another log to go another foot higher. And it's just a concrete wall, so I'd anticipate just going another foot up is robust. Yeah.
Any other questions?
Just a question, because I wasn't involved in the earliest stages of the planning around the Resilience Hub. It seems like power less than the equivalent of 2 Ford F-150s doesn't seem like a tremendous amount of charging power. So how was the determination to make it at 242 kilowatt hours? How was that evaluated and decided upon, and or has there been any consideration of going for more? Is Sean going to answer? Is that why you're pointing at him? Just to understand sort of the energy needs and requirements there provided by that battery.
Yeah.
This is Sean. Do we have Gaurav here?
I have somebody from Greenscape attending.
Yeah, Greenscape would probably, or ND5. But just to answer the question as much as I can, we went through a lot of iterations looking at the battery size, the solar cell size, and in terms of maximizing power and giving us as much as we could get with the largest solar array that we could handle in terms of space. And one of our biggest constraints was actually where we could put solar panels and space. We looked at putting them on town hall roof. We looked at putting them in the library. We looked at putting them in the police lot. We looked at putting them over in Magnolia. And ultimately, we decided Magnolia for the solar panels. But best person to answer is probably NV5 as far as the ultimate size that was picked, because I don't remember it off the top of my head. Or Gaurav maybe can answer that.
Yes. Yeah, thank you, Sean. Good evening, everyone. Yeah, so we actually use the 15-minute interval data to size the battery and the solar system. Currently, the electrical room that is in the police department, it has a maximum peak demand of 56 kilowatt, which is much lesser than what we are proposing, and that the proposed system will cater the future loads also. We are adding 3 EV chargers also, dual port EV chargers. So we will be targeting the existing load as well as the any future loads of the police department. So it was based on the 15-minute interval data.
Got it. Okay. Thank you.
Yeah, thank you.
Any other questions? Any comments from the public?
Yes. Well, Guy Meyer here again. I think, though, indeed, there's been a process that you've all been involved in to get this going here. I think the community really doesn't know too much about what's going on. I think Av's asking a legitimate question, and a lot of questions have come up just recently. We're just so. If you look, there are so many fires being reported throughout the planet. A couple of comments here on the CEQA issues. Because it can be exempt from CEQA, like no looking, Earth Day here. Because it can be seen with certainty that there is no possibility that the activity in question may have a significant negative impact on the environment, it's exempt from CEQA. Now, this is the status of what we're at right now on the planet, be it left or right. Coastal Commission, CEQA is, back in the 1970s, it was a gift to California. It was a battle to have this California Environmental Quality Act. We have a new AB 434, Safety and Secure Battery Storage Act, has just been coming to fruition, introduced into the Assembly, not voted on yet, not examined. People are looking at this and they're going, let's take stock. Let's take stock of what's going on in Moss Landing. The people who had, yes, 4,000 times larger. This is a small system compared to Moss Landing. But we have Teslas burning up. It happens a lot. And then Nature publications, one of the top-rated science publications in the country, on the planet, states in their study from last summer that lithium-ion battery components are at the nexus of sustainable energy and the environmental release of per- and polyfluoric alkyl substances. That's PFAS, all lithium. Results underscore that environmental impacts of clean energy infrastructure merit scrutiny to ensure that reduced CO2 emissions are not achieved at the expense of increasing global releases of persistent organic pollutants. These guys, these scientists, these group of scientists are making a statement to the world. Pay attention. What are we rushing? I think we're rushing here, even though I know you've done due process. The BESS system has numerous VL and NFPA safety certifications, as well as California's fire safety compliance. I'm sure the one down in Moss Landing had all that too. They were in awe of how safe.
Thank you, Guy. Todd.
Hi there. A couple quick comments. This is meant to be a resilience hub. Great idea. Glad that you're doing a microgrid. Really good to hear. Question is, what is the height at which this will be installed, since San Anselmo has been prone to flooding in the past? Is it going to be installed at a sufficient height for safety during the highest flood that we've had before? And then in the name of resilience, I know there is some movement against it, but resilience to me means that you can deal with all kinds of adversity, not just with a battery, not just with solar that only works on sunny days. Has there been any thought about including a gas-powered generator that would link up to this, that would charge the batteries when the grid was down, since we have so many power outages here? Thank you.
We already have a generator.
We're not.
That's what it'll be
doing.
powering.
No, just done. That's what yes. Okay. All right. Any other comments? Let's see. Online, we have Sue Saunders.
Sue, you've been unmuted.
Thank you. Good evening, Town Council members. I just wanted to address the safety of batteries, and I know there's been some concern in our community, but the reason the Moss Landing has had such battery fire problems is because it really wasn't designed or constructed properly. The batteries are right next to each other. They're not separated, so if one battery catches on fire, it quickly spreads, and that's one of the problems there. And, you know, there are problems with any kind of technology we try. With generators, there's carbon monoxide poisoning associated with diesel generators. And natural gas that runs under our streets and homes are an explosive fire risk. But nobody suggests we stop using natural gas. Although we should, because natural gas is 90% methane, which is increasing climate change, which is why we're all in this position in the first place. Of needing a resilience hub. So no technology is 100% safe, but I know that we need some kind of resilience. And, you know, for climate change, certain individuals may not believe in it, but the homeowners and car insurance policy people believe in it. And that's why our costs for to insure our homes and cars is going to go right up. And, you know, periodically I consider where do I want to move where I will best be positioned to, survive what's going to be some really horrific consequences because we haven't addressed climate change yet. And one of the things I read is that you don't necessarily want to leave where you live because you're going to need your community. So we have fantastic community here. And they also said you want to live where there's resilience. And so having this resilience hub, having all the steps the town has taken to create a safe environment for us and planning for the future, we're really way out front on this. It's made me realize that I don't need to leave here, and this is actually where I need to be. So I really applaud this, and I do not worry about any battery fires. And I think this is one of the safest technologies we can use to power ourselves in the event of power safety shutoffs or extreme weather emergencies. So thank you.
Thank you, Sue. Any other comments online? I don't believe anybody else is online. Okay, I'll take it back to council for comments.
Yeah, I'll kick us off. I was proud to be one of the leaders of this project with former council member Feynman and a lot of our climate action warriors in town, like Kathleen Gundry, Karen Mendelau, and Sue Saunders. I think for me, solar's always been a no-brainer for municipalities. It gives us we could see a return on this investment. The amortization long-term makes a lot of sense, but what's most important here is that and this is where staff deserves just a lot of credit, right? Because we're under this deadline for the net energy metering 2.0, right? And we're just getting under that deadline, and that's going to allow us to receive the full retail rate for any excess electricity that we send back to the grid. We're getting a lot of the funding that's going into this reimbursed and covered from both the federal and state government. And so, I think back to the 2019 public safety power shutdown, where we were down for a few days, and our library and town facilities became a hub for people to come and get cool. It was October, but it was very warm then. To charge their phones, to do what they need to do, and also be in a community. That was something that was really near and dear to my heart. And when we talk about how our community steps up in these times, that was really our town being a resource to our community. For us to be able to do that without using gas-powered electricity, that just is a no-brainer. Not to mention we again get to sell any excess electricity back to the grid at full retail. So. This is really where I think the future is going. I'm big on solar. You'll hear more from me on that on a future agenda item tonight. But this is really a proud moment for our town. We're it's not the biggest project in the world, but it's a project that is going to provide us a resource that we could use in a time when not just our town, but our community needs it. And so I'm fully supportive of it and look forward to getting this project done.
I have a few comments. First of all, thanks for the safety update. I mean, that was really what the report is about, is because we had concerns, and you've answered them, and I appreciate that. It is, it does highlight, however, that this is not going to give us all that much power, but it's a step toward what we want to do more of. I don't know how much we're going to be selling back to the grid. It doesn't look like very much, but we are under net 2.0 if we do. And we're almost there, so happy to see this get done.
Any other comments?
Yes. I want to say thank you for the report, but also just the progress. San Anselmo is actually a leader in this area around resilience, around climate action. Having both looked at this project through the lens and sitting with our climate action committee, as well as having read a lot about it, both before taking this seat and then after. It's excellent that we're making progress in this direction, and it also has taken multiple councils to get that done. And I hope we continue to expand, not just meet the minimum standard, which we are, and we're exceeding in other ways, but keep moving forward with safety and with ongoing communication and good science.
Yoav?
Great update, thank you.
Everything's been said. I don't have anything to say. We don't need to vote on this. It's just a report. So I'm suggesting we take a 5-minute bathroom break. We've been meeting for 3 hours now. I'd like to stretch my feet a little bit.
This is called black mass. It's made of rare metals recycled from lithium ion batteries, the kind that power most smartphones, laptops, and electric cars. Less than half of these ever get recycled. Electric cars are supposed to help the planet, but could their batteries create the next trash problem? And why are those batteries so difficult to recycle? The batteries from traditional gas-powered cars, called lead-acid batteries, are made mostly of, well, lead. And they're highly toxic if they end up in a landfill. But in the U.S., strict laws in most states mean that almost 100% of them get recycled. Most electric cars, on the other hand, use lithium ion batteries. They're not nearly as toxic as lead-acid batteries, but they're much bigger. And sometimes, lithium-ion batteries explode.
A lot of companies have shied away typically from handling the material because of that core safety challenge.
Li-Cycle's founders started the company in 2016 to find a safer way to deal with this waste stream and to capitalize on a growing market.
We saw recycling as the glaring hole in the supply chain.
Only about 5% of cars sold globally in 2020 were electric, and these batteries will last about 10 years. By that time, there could be almost 100 Eiffel Towers worth of used-up lithium-ion batteries to recycle.
Many people think, isn't recycling just needed like 10 years from now?
And the problem is already here in the form of leftover scrap and rejects from battery factories.
There is a tsunami coming at us.
And the process is the same one used to recycle smaller batteries from phones and laptops. One of the first steps is dumping the batteries onto tables to shake off a flame-retardant packing material called vermiculite.
We'll tip it up onto the first screen and we'll remove that vermiculite material before it goes onto our first feed conveyor.
Companies make batteries in different ways, but the founders say they found one recycling method that can handle them all. And they can process large electric car batteries with almost no disassembly.
Other groups will typically dismantle manually to get to a cell level. At that sort of scale of a pack, you have potentially thousands of cells.
Instead of that, this system slices lithium-ion batteries into confetti-like shreds. Because these batteries can catch on fire under pressure, you can't just throw them into any old shredder.
When you crush a lithium-ion battery, say in a device, it short circuits. And that short circuiting is what can drive a thermal event, aka fire.
So how does Li-Cycle shred the batteries without blowing them up? The founders keep some of the details secret, but a key part is the liquid that's hidden inside this shredding system.
There's no oxygen there. Without oxygen, there's no fires.
That liquid also helps separate the plastic, which most recyclers just burn away.
As the batteries were being broken up, the low-density plastic is floating up to the top. We separate it out, we bag it, ready for our customers.
Li-Cycle plans to have this plastic recycled at some point, but wouldn't tell us where it currently goes. Machines separate what's left in the system into two categories: metallic foil and black mass.
So behind me, we're bagging that metallic foil, and we sell this for the copper content as well as the precious metals.
The most valuable metals are in the black mass.
Black mass contains the nickel, the cobalt, manganese, graphite, lithium, etc.
Experts say that if current trends continue, the world could run low on battery metals like nickel and manganese in less than a decade. 1 metric ton of black mass, the amount in each of these bags, is worth about $3,500. Chemical treatments can separate the rare metals out of it, but Li-Cycle's chemical facilities aren't up and running yet. So for now it has to ship the black mass to a smelter. Smelting uses chemicals and extremely high temperatures to purify metals. It requires a lot of energy and creates pollution. This method gets nickel and cobalt from the black mass, but the rest of it goes to waste.
They can't recover the lithium, they can't recover the graphite, so there's a lot of value that's left behind.
Li-Cycle's not alone. Most lithium-ion battery recyclers don't recover lithium. But the founders say they're building another plant next to this one that will recover everything. This could reduce the need for mining, which contributes to global warming, contaminates soil, and can involve unethical labor practices. Once the company is recovering all the metals, for every ton of batteries recycled, the founders say they will avoid 5 tons of CO2 emissions that would have come from mining new metals. And they say recycled metals are cheaper than mined ones, too. This could lower the cost of electric cars, which experts say is a good thing, because even though the batteries take a toll on the environment, electric cars are still better for the planet than traditional ones.
EVs are much more efficient than they were 5-10 years ago. It's better for the environment from a greenhouse gas perspective than driving an internal combustion engine car, because we've seen all these performance improvements both at the vehicle level and in our electricity grid.
Right.
This kind of money selling from our yard tools to your laptop, most of us have those rechargeable lithium-ion batteries in our homes, but they might not be as good for the environment as you think. This is according to research now, a team led by a Duke professor. WRAL climate change reporter Liz McLaughlin explains the pros and the cons.
From electric vehicles to battery storage, lithium-ion batteries are powering the clean energy future. But Duke's Lee Ferguson and colleagues found the production and disposal of these batteries are a troubling source of forever chemical contamination.
And we found bistriflamide actually in those batteries in surprisingly high concentrations in some of them.
Researchers looked at a new type of forever chemical, or PFAS, used as a conductor in batteries, with similar properties to Gen X.
Energy storage is critical, but we need to make sure that we're not using regrettable compounds and materials that could prove problematic for the environment down the line.
Researchers found the unregulated and little-researched new PFAS chemical near lithium battery manufacturing sites across the globe and leaching from landfills across the Southeast, including in North Carolina.
The vast majority of lithium-ion batteries are actually ending up in landfills,
adding to an already out-of-control pollution problem. PFAS chemicals are present in more than 300 drinking water systems in North Carolina.
Hopefully people can take away from the study a cautionary tale that we could do this differently and that we have that opportunity to do it differently now.
A push for more research into battery components and more responsibility from cradle to grave as clean energy technology ramps up. Liz McLaughlin, WRAL News.
And this stat here will give you some perspective. As little as 5% of lithium-ion batteries are recycled, even though the components can be reused. And if battery recycling isn't scaled up, a projected 8 million tons of battery waste could end up in landfills by 2040.